All right, we'll look to finish up section 1.1 here in the notes. So I guess the next thing to talk about is a little bit, just a little bit with circles. It says the definition there says the standard form of an equation of a circle with radius r and center point located at the point hk is the equation x minus h squared plus y minus k squared equals the radius squared. Okay, so let's take a look at an example of this. In this example, suppose that we have a circle that has a radius of 3, and the center point of the circle is located at -1, 2. There's a couple of things I want us to do with this circle. So the first thing is, let's go ahead and write the equation of the circle with this information known, the radius in the center. And then after we have that, we'll go ahead and graph the circle. So in standard form, let's see, I gotta write the equation x minus h squared plus y minus k squared equals the radius squared. So all I have to do is identify, what is r, what is h, and what is k, and then plug in those numbers in this form. So it looks like r is 3, h is -1, and k is 2. So I'm going to have x minus a -1 is the same as x plus 1 squared, plus y minus 2 squared equals, the radius is 3, so 3 squared is 9. Okay, and then I'd circle that equation there. Let's go ahead and graph this circle. So when you graph a circle, usually you'll plot the center point, and then you work off of the radius, and then you'll build like 4 points around the center, and then you'll draw a circle as best you can type thing. Okay, so the center point of the circle is located at the point -1, 2. I'm in quadrant 2 there. And I'm working with a radius of 3. So if I go 3 units to the right of the center, then that would bring me to the point 2, 2. I'd plot that point. 3 units to the left of the center brings me to the point -4, 2, and I'd plot that point. 3 units above the center brings me to the point -1, 5. I'd plot that point there, and then 3 units below the center would bring me to the point -1, -1. And then once I have these 4 points plotted, I can then draw a circle as best I can. Okay, now when you're drawing circles, like, I don't expect to be artists, okay, but like any other graph, try to be neat with your drawing, okay. Now the next thing here is the basic functions. So there's basic functions that are on page 12 in the book. And let's see, so page 12 is right there, and they have these different functions given. It looks like there's 9 of them, okay? Now, what I would like us to do, and I've got a handout here of this, is I would like us to, take a look at the graph of each function, and then we'll state the domain and the range. Okay, now the domain and the range are things that we'll talk about in the next section more in detail. The domain of a function is the set of all input values, so what's going into the function, the set of all x values, and the range of the function is the set of all y values, or the set of all output values, so what's coming out of the function. And there's a difference between what's going in and what's coming out of the function, okay? Now, on this worksheet here, I got, looks like 8 functions, and here's the next page. So all I want us to do is to identify, the domain and the range of each graph, okay? So the first graph is called the constant function, and f of x equals b, where b is a constant, would be the equation of this graph. Okay, now b can be any number. So it looks like on this graph I got b is, about 2.7 or whatever. B can be any number though. The domain would be all the x values. Well, here, it's not going to matter what x is. X can be any number. And you plug in that number, you're always going to get b in return. So if I scan the x-axis, look above and below at each spot, if I'm on the curve, I'm in the domain. If I'm not on the curve, I'm not in the domain. Well, again, here, it's not going to matter where you're at on the x-axis. If you look above or below, specifically above for this problem, you'll be on the curve. So the domain would be all real numbers. So any number is possible for x. Okay? The range of the function is the set of all y values. So if I scan the y-axis and look to the left and the right of each value, if I'm on the graph, I'm in the range. If I'm not on the graph, I'm not in the range. Okay, well, in this problem, it looks like whatever the b value is, here's b, if I look to the left and right, I'll be on the graph. Okay, so and b would be the only number in the range of the function there. Okay. The next curve to know is the identity function. The identity function is a line flowing through quadrants 1 and 3, and it has the equation y equals x, or remember, y and f of x mean the same thing. So if we use function notation, f of x equals x, that means the same thing as y equals x. Okay, and so here's the graph of the identity function. And the domain is all real numbers. So I can let x be anything I want here. Again, the arrows indicate that you're heading outward in both directions. You're going to cover the entire x-axis. Okay, so it's not going to matter where you're at on the x-axis. If you look above or below, you're going to be on the curve. Okay, so it's all real numbers for the domain. And the range is the set of all y values. Well, if y is x, and x can be anything, then y can be anything, right? So, if I scan the y-axis and look to the left or the right, if I'm on the graph, I'm in the range. Well, here again, it's not going to matter where you're at, right? So if I'm at -3 and I look to the left, well, I'm at this point on the graph. Okay, or if I'm at 4 and I look to the right, I'm at this point on the graph. Okay. Again, the arrows indicate that you're going to head outward, and in both directions there, you're going to cover the entire number line. Okay. The next curve to know is the square function. We're going to do lots of things with the square function coming up. The square function is a parabola. So the equation is y equals x squared, or f of x equals x squared. That's the same thing. And just the most basic graph of y equals x squared is where you have a parabola centered at the origin facing upward. The domain is all real numbers. So I can let x be anything. I can square any number I want. It would be one way to say it. The range is asking for the y values. So if I scan the y-axis, anything that's 0 or bigger is going to put me on the graph. Now, I didn't really need a graph to get the range, right? Because I know that if I square any number, I never have a negative as the result. Like if I square 3, I get 9. If I square -3, I get 9, right? So I'm never going to have a negative coming out of this. 0 squared is 0, right? So anything that's 0 or bigger is going to put me in the range. The next function to know is the cube function. So y equals x cubed, or f of x equals x cubed is the equation. The graph is in quadrants 1 and 3, and there's a squiggle in the graph right at the origin. And the domain and the range of this function. So I can let x be anything, right? Like I can cube any number I want, and I just get another number in return. Okay, but the point is that I can cube any number I want. The range of the function will be all real numbers. See, unlike when you square a number, you'll never have a negative coming out of that. That's not true when you cube a number. Like if I cube -2, -2 cubed is -8. So the point -2, -8, that's off the scale I've got, but that'd be down here. That'd be on the graph, right? And 2 cubed is 8. 2 times 2 times 2, that's 8. Okay, so 2, 8, that'd be up there. So you're going to cover the entire y-axis. The range would be all real numbers. Okay. How about this one next? So the square root function has the equation y equals the square root of x, or f of x equals the square root of x. And the graph is starting at the origin and curling upward and outward towards the right into quadrant 1. Okay, actually what we're looking at is a half of a parabola. A complete parabola kicked on its side facing towards the right would fail the vertical line test, so that would not be a function, right? And so I'm only looking at half of a parabola. Okay, the domain is all positive numbers. So I can't take the square root of a negative. Actually, the square root of a negative is an imaginary number. We're going to talk about imaginary numbers in another section in chapter 3. Okay, but the square root of a number that's not a negative is a real number, right? So anything that's 0 or bigger would put me in the domain, okay? And I can also get that by looking at the graph. If I scan the x-axis, anywhere that's 0 or bigger is going to put me on the graph. I don't want x to be a negative, right, because I don't have any graph over here, okay? The range is asking for the y values. So what's coming out of the function? Well, that's going to be the set of all y such that y is 0 or bigger. Okay, so and I can get that by scanning the y-axis, and anywhere that's 0 or bigger, when I look specifically to the right, I'm going to be on the graph. Okay, I don't want y to be a negative because that means I'm down here, and I don't have any graph down here. Okay, now I think that should make total sense to us. If I ask you the square root of 9, the square root of 9 is 3. It's not -3, right? It's 3. So you're always going to have some non-negative number coming out of the function there. Here's the cube root function. The equation f of x equals the cube root of x. Okay, the domain is all real numbers, so I can take the cube root of any number I want. Okay, the cube root of 8 is 2 because 2 cubed, 2 times 2 times 2, that gives me 8. The cube root of -8 is -2 because -2 cubed is -8. If I take -2 times -2 times -2, I get -8. Okay, so unlike with the square function, like the square root function, the cube root function, like you can have negatives underneath the radical, and that's okay. There's no problem with that. Okay. Now the range of the function is also all real numbers, because you can have a negative coming out of the calculation. Like again, if I ask you the cube root of -8, that's -2, because -2 cubed gives you -8. -2 times -2 times -2, that's -8. Right, so I got -2 coming out. So that means also that the point -8, -2, that would be on the graph. Again, that's off the scale that I've got there, but that point would be there. Here's the next curve, the reciprocal function. Okay, the reciprocal function has the equation f of x equals 1 over x. We're going to do some things with the reciprocal function in chapter 3 once we get there. Okay, the graph is in quadrants 1 and 3. The domain is anything but 0. I know in math I can't divide by 0. Okay, so division by 0 is not allowed. And also, because I can't plug 0 into the function, there's no other number that's going to return 0. So y can't be 0. Okay. When we talk about this later on, we'll talk more about the reciprocal function and functions in fractional form and how you got to pay attention to the denominator, and also any asymptotes that would be on the graph. We'll talk more about that in another section. But anyway, the last one they got there is the absolute value function. The absolute value function is the most basic graph is y equals the absolute value of x, and that's always a v-shaped graph centered at the origin, facing upward. So the domain is all real numbers. I can let x be anything I want. In other words, I can take the absolute value of any number I want. Right? The absolute value of 3 is 3. The absolute value of -3 is 3. The absolute value bars just mean that you're gonna take the positive of the number. Okay, so you're referring to the distance from 0 to -3. That'd be 3 units. Okay, so the absolute value of -3 is 3. Okay, the range of the function is all non-negative numbers. Okay, so like if I ask you the cubed root, the absolute value of -3, that would be 3, right? So so anything that's a positive is going to come out of this, and also I can get that by looking at the graph. If I scan the y-axis, here's 0. Anything that's bigger than 0, when I look to the left or the right, I'm on the graph, right? I don't want anything negative. That means I'm down here, and I don't have any graph down here at all. Okay, we're going to do lots of things with the basic functions. So the basic functions are really just to give us a place to start with. We're going to build on the basic. We'll build on the basics, of course. And so, all right, we'll go ahead and stop the video right here. Here's the homework in section 1.1 that I'd like you to look at. Okay, we'll start section 1.2 in the next video there.